it landed on the lunar surface successfully.
So, and have you seen the other videos of what the rover is doing?
No, sir, I have not watched the videos about it. Sir.
Okay. A lot of videos have come. I think your father will help you to get those videos and see them. So, will you go to the moon now?
What, sir?
You want to go to the moon?
No, sir.
No. Why? Why you don't want to go?
Uh, many things could go wrong.
You see, Neil Armstrong went there. He came back. Now many people will go. If India is
And sir,
also planning
Rakesh,
to
Rakesh
send.
Roshan was also went in ancient time. Rakesh Roshan,
No,
something.
not Rakesh Roshan. That is what is. I think there is some political leader. He is saying Rakesh Roshan is a film actor. That was
No,
Rakesh Sharma.
Rakesh Sharma. Yeah, yes, yes. Rakesh
No,
Sharma.
but
Yes.
he didn't go to moon. He just went in the Russian rocket orbiting around the Earth. So, but now India is planning to send someone to the moon. I think they are going to send also something like one robot also they are going to send which will orbit the Earth and then it will come back. Then they will try with a robot again going to the moon and again coming back. So, Pankaj, are you looking into the different videos which are coming out from the ISRO?
In
Hello?
that day, we seen sir live, but
Uh, yeah, no, ISRO is just, giving out not many videos, very few videos. They have put it in their website.
yes, sir.
So, so what about your other people, other young people?
Yes, sir.
सब खाना खा रहे होंगे नहीं?
Sometimes. So, Aryan, please say something regarding Chandrayaan 3. What's your opinion? What's you seen?
Yes, sir.
Because last Saturday we have only think what will happen, but today we have result. Yes, successful.
Chandrayaan 3 is a lunar exploration mission by the um, Indian Space Research Organization. It is the third mission in the Chandrayaan series after Chandrayaan 1 and Chandrayaan 2. The primary objective of the Chandrayaan 3 is to land rover on the moon's surface and conduct extensive scientific research. The rover landing in Chandrayaan 3 will be similar to the one attempted in the Chandrayaan 2. Consists of a lander, a rover, and an orbiter. The lander will carry the rover to the lunar surface where it will deploy and begin its operation. The rover will explore the moon's surface, collect data, and analyze lunar soil and rocks contributing to our understanding of the moon geology and its evolution. ISRO has been working on the modifying the lander and rover design based on the lessons learned from Chandrayaan 2 mission. The aim is to overcome the issues faced during the Chandrayaan 2 attempt landing in September 2019. The specific details about the modifications and the timeline of Chandrayaan 3 launch and mission are to be announced by ISRO. I mean, and they initially planned to launch the mission on 2020, but it got delayed many times. Chandrayaan 3 holds significant importance for India's space exploration ambitions as it aims to demonstrate its capability to successfully land a rover on the moon's surface. It will contribute to the mathematical knowledge about the moon, ocean, missions, and potential human explorations. Hello.
Oh, good. Yeah, very nice. So, what do you think, Aryan, is the why people say it is very difficult to send this kind of rocket to the moon? What is the difficulty?
Yes, sir. We have to do many things correctly. We need to design the rovers, landers, and orbiters.
Hmm.
We need to be perfect and land the um, spacecraft to the moon.
No, so what is the difficulty? Where is the problem? Everybody should be able to do it, no?
Yes, sir.
What do you think is the difficulty? Where is the difficulty? Why only for you see very few countries have sent to the moon,
Sir,
only four countries.
sir,
What is the
in landing
difficulty?
and launching period, there are some problems.
What is the yeah, what is the problem in landing? वो तो
Sir,
gravity है, वो तो land करेगा. If you send something there, it is going to land on the moon obviously. So what is the
sir,
problem?
if it crashed land in a crater or it some part of it got damaged.
That is correct. Very good. So how do they solve this problem?
Yes, mm,
Hmm?
yes, sir.
How do they solve this problem? You see, anything, suppose you throw a stone up. So when the stone goes up, it somewhere it goes, then velocity, speed becomes zero. Then again, when it comes down, the speed keeps on increasing, isn't it? Because of gravity. A similar thing will happen to that rocket also when it will be going towards the surface.
But when it's
The speed will
landing, it
increase.
should be
Huh?
but when it's landing, it should have a low velocity.
How to do that? Suppose a stone, if you throw on the moon from a height, then the speed of the stone will be increasing because of gravity. नहीं? यहाँ पर भी तो, isn't it? If you are throwing a stone in your house, it will go up, and when it comes down, the speed keeps on increasing. Same thing will happen to that rocket also. If it is falling down on moon, speed will be increasing because of the gravity. So how to reduce his speed?
Sir,
वहां पर तो
and
you see there is no atmosphere, almost negligible atmosphere. Like the planes, planes, they use the atmosphere to move around. But वहां पर तो सो भी नहीं है. So how to do it?
sir, I have a presentation in my mind, but I don't know how to present.
But you can do
No, no, say.
You have a good speaker. If you think about speak.
So didn't you see in the TV that you see there was a rockets, rocket in the sense that there was a flame which was coming out. Did you see that? So in opposite direction, if you put the suppose that fuel comes down, then the rocket will try to give a opposite velocity to the what the gravity is giving. No,
Yes, sir. It will push.
yeah, you must have seen there were four things were fired to reduce the speed. So
Yes, sir.
gravity was trying to bring it down, and those four they were fired so that it reduces the velocity. In fact, the direction also was changed by firing only two of them. If you fire only two of them, then the direction also will change.
Oh,
So you must take a good look at all the videos which have come out and see how. So then you can also plan to go to moon. Now, Pankaj ji has also joined us. Pankaj ji, namaskar.
And
Yes,
sir,
sir.
No,
I
no,
only,
no, no, no.
I
Yeah,
have only
Pankaj ji is already
yes,
there. Yeah,
yes, sir.
sorry.
yes, sir. I would like to say that, sir. Actually,
Yes,
Yes,
Navin
it's
ji.
not audible. हाँ बोलिए जी
जी
हाँ
sir. Aryan got the opportunity to talk to ISRO scientist
ओ
last
ये
2 days ago, sir. He's
ओह
working.
वेरी गुड
Uh, when he when his video is watched, then he contact with them, sir.
ओह वेरी गुड
Yes.
so what did they say to him?
Aryan,
So Aryan, please say something else regarding what you discussed,
yes,
what
sir.
they told you.
Sir, sir, we uh, the scientist said that you should focus on basic maths and big decisions would be taken after or in the 10th grade. They told me to improve maths.
Maths, yeah,
Yes,
very, yes, correct. So you must know maths, you must know physics, so and then you can become an astronaut, you can or you can also learn how to now if you do engineering then you will know how to control. And you see, there was a lot of artificial intelligence also built in that. When uh, the rocket, the lander was coming down, so there was no communication with the Earth. So it was that artificial intelligence built in that, decided everything, how to go down, where to get down, and things like that. Why? Because it takes 1.5 seconds for the signal to reach there. So any signal which will come from there will come to us in 1.5 seconds, and again when we send it 1.5 seconds. तो 3 सेकंड में तो रॉकेट कहीं से कहीं चला जाएगा वो.
Yes,
yes,
So
sir.
sir.
there are so many
Sir,
things
and how
built.
so, sir, and how are we capturing it photos of it photos and on the
No,
Chandrayaan? We-
yeah, photos there they can send, but suppose I want to control from here, then I need the signal to come immediately, but in 1.5 seconds the rocket can reach anywhere, you see. How much was the speed initially when it was moving around? It was 6,000 kilometers per
Oh,
hour.
sir, or 1 kilometer per second, I think.
Yeah, and then they brought it down to that speed, 1.5 or something, 1.8.
Yeah, sir.
Had it
I
come
was
with,
very
had it come with more than 3 kilometer, then per hour, then the whole thing would have crash landed because the thrust was not built for more than three.
oh,
So it was a very good landing. So you can plan to become an astronaut. You can you have to learn physics. You have to learn electronics engineering. You have to learn telecommunications. You have to learn artificial intelligence. So many things you have to learn. You see. And there are different experts are there in ISRO who handle these things. So it is a very collective effort. Lot of people contribute to make it successful.
okay, sir.
Yeah.
It's totally teamwork, yes, sir.
It's a very big teamwork because
Sir, and it was delayed many times too. It was
uh,
they were planning initially to launch in the late
no delay means a delay can always take place. You have to because we have to
Yes,
learn many things. Every time there is a fault, we have to learn, we have to repair, we have to think new ways to do things.
yes, sir.
So a lot of planning goes. So delay is okay. I mean, delay is not a problem.
So,
Yes.
so can you guide me for books? That book.
Yeah, I always you tell me, and I always no books I know, but I'm just looking for books which will suit you actually, which I'm
As
not
per
get.
Aryan age, yes, sir. Due to
Yes,
age, it is only
yes,
9 to 10 years old. So
yeah, and
book
already
is a
you
lot
know
of,
so many
but
things.
which book is good for Aryan? It's
So I'm looking for somewhere something like 12, 13-year old child. Aryan is 10, but he needs a book which is 13 years old. But I'm not getting it.
so I think Aryan needed some a waiting
Yeah,
to
but whatever you have, no, you start, learning them. By learning, what we mean? By learning, we mean that you try to understand them, each one of them. You question it, that why it is correct, why it should happen like this, why not like that, and that is how you learn. That is called learn. So if you do that, what book do you have on astronomy and things? Do you have any book with you?
Yes, sir. I have one book, but has two parts. Um,
Yeah. What is the name of the book?
then I don't remember it. Uh, yes.
Yeah, usually this.
It has almost 500 pages.
No, I saw a book which I thought we written for young people, but already I saw that you already know everything in that book. So I need to find another book which is more advanced so that you will get something new to read.
So,
But then in the meantime, you have to learn physics and mathematics and
yes.
also a bit of chemistry, you see.
I,
See, even rover, but this lander which has gone Vikram, that has got, they have going to do experiments, which is a chemistry experiment.
oh,
Chemistry in the sense that they will take materials and they will try to identify what it is, whether it is aluminium, whether it is magnesium. So they'll be doing it. Have a spectrometer. So,
Now Brenda is joined, sir.
oh, yeah. Good morning, Brenda. She's on mute. Yes.
Good morning.
Good. Yes. Good morning.
How are you
Did
today?
you hear about the Indian moon landing in
Yes.
Mexico?
Oh,
So,
in Mex,
yes.
you mean to the mission?
Yes. The moon mission, which was successfully done on 23rd.
Yes, I hear in the news about the
Okay.
mission.
So people in general in Mexico, were they happy about it?
The truth is, in Mexico, I think don't have this type of like a interest. I think is that because I never hear in Mexico one institution like a ISRO.
Oh yeah, it will come very soon. It will come. So,
But some people I
so
think is interest in in things
um,
like a sky, galaxies, a new universe.
so did they show in your TV, in Mexican TV, about this Indian moon mission?
Yes,
Oh, and the newspapers also it came.
yes, I see in a no newspaper. I see the news in a like a news online.
Okay. What about TV? On the TV they didn't show it, is it?
Yes, I see in the TV. Not
Acha.
Washar
Yeah.
in a
But
No.
sir, I seen, sir, in 24th August,
Yes.
maximum country broadcast as like breaking news. This
Oh.
in
Oh.
South Pole reached, yes, sir, in the West, Singapore, maximum country like breaking news. Whole day, 24th August is only name is Chandrayaan India, Chandrayaan India. That's like,
Oh yeah, right. No, in the world, all the big newspapers they reported it,
yes.
but I don't know about it. So, so Mexico right now doesn't have a space program, isn't it, Brenda?
yes, I think this is true. I never see this program in Mexico.
No, it might be there. I mean, it may not be getting good funding, no, because once they get fund, no, they will start working on it, but they may not be getting funds for space research.
Yes,
In
Aryan, you have
India,
a question? And
Yes, sir. Sir,
yes,
I want sir, about I have questions about supercomputers.
supercomputer.
That yes, sir. And that Google has which could do work that takes 10,000 years in 300 seconds. I forgot the name.
10,000?
Uh, if a normal computer does one thing in 10,000 years, uh, and the same work is done by the supercomputer of Google, it
Hmm.
would take only 300 seconds. How is it so fast?
Yeah. So,
For the reason supercomputer name is supercomputer, yes, and normal computer. It's a big difference.
No, sir, I
Achha,
think the
this answer
quantum.
will be given by Pankaj. He is our computer expert.
No, 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 sir. I'm not expert. Supercomputer. Brenda has a lot of idea because she's
He's working
computer
in.
science.
Yes,
Yeah.
yes.
Brenda, do you have any
Yes.
difference between normal computer and supercomputer? What's the difference between normal computer and supercomputer?
Yes, I think that supercomputers have a high performance. I think they have the reduce the time for resolution of problems. I think these type of computers have the capacity to detect like a tsunamis. I
Mhm.
never see supercomputers, physical supercomputers, but I
Yes,
see in the news.
supercomputer. I think supercomputer is not available for normal people. Yes.
Yes,
Yes. Yes.
I think this type of supercomputers is in big companies like ABM. I
So,
think Amanagiser had more.
yeah, yeah. He has worked on that. But the basic difference, Aryan, is like this: the speed. The speed means how fast you can change. Say any memory. Suppose you are putting, zero or one. All computers they work with zero and one binaries. So how fast you can do that? So earlier it used to take some time. Now because you see that day Amarnath ji was explaining that 14
Yes, sir,
nanometer,
it
you see,
uses.
14
I think.
nanometer, 10 nanometer, then 6 nanometer. So as this distance decreases, the speed increases. You know, I worked in my 70s, late 70s with a computer. I used to put simple programs I used to give for calculation, and that time that was a what you call. I used to first there used to be a card. You may not have seen all these things. I worked in a computer which was the only computer in India that time. So we had to give card, first to write the programs on a card in a punching machine. Then we used to feed it to the computer, and that had a memory of something like at that time was about 100 MB. 100 MB, is a memory now you get in pen drives. Gigabyte you get 16 GB, 64 GB, now 500 GB, even 1 terabyte GB you can get in a pen drive in a small hand. But that computer had a memory of 100 megabyte. So obviously, if the memory is less, the number of operations which you can do becomes very much limited. So a supercomputer has a chip which is fast, number one. Number two, it has a lot of huge memory. And it can do parallel processing. In parallel, you can solve a problem. These three characteristics, they make a supercomputer a supercomputer. So nowadays it is becoming very fast. Even this quantum thing, which is coming up, quantum
It was.
computing, that is still faster. That can do this change, things very fast, even compared to the present day chips. So you will
Yes.
have more of it. You can solve the problem in parallel processing, means any problem will be broken down into smaller problems, solve it separately, parallel way, and then solve the, you know, so it makes the solution very fast. So like they suppose I want to track the weather and I want to predict, or say as Brenda was telling tsunami and all that, there are so many parameters. So you need very fast computing and you need huge space, huge memory space. And the
Yes.
rest of it, all the details, I think I will ask when Amarnath ji comes, because he has worked with them, so he will tell you. I had my first supercomputer working sometime in 90s, 90s when it came to Kolkata, where I stay. So that is the first time I worked. But that supercomputer nowadays has become a normal computer. Now still faster computers are there.
So there would be a time where we use quantum computers as normal.
Oh, that is true. Yes, yes. You are very correct. Yes. But then it needs, a lot of brain to develop it, and they are waiting for Aryan to grow a little bit.
Oh,
So
sir, but a normal computer uses bit and a super or quantum computer uses qubits.
yeah, there are different ways of doing things, but ultimately it boils down to this: having large memories, having faster chips, and capability to do parallel processing. And these are the three basic things. There are many other things which are required. How they do it, it's a field in itself.
Oh, sir,
Yes.
sir, can I talk about the Chandrayaan 3 rover?
No, you must try to explain to us what are the things. What are you going to talk? What is the
Sir,
topic?
about what it is going to do on the moon.
Yes, 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 yes. So why don't you talk? Yes, explain to us so that we can understand. Yeah, go ahead.
Yes, sir. Chandrayaan 3 is a lunar rover mission by the Indian Space Research Organization. It is a follow-up mission to the Chandrayaan 2
Hmm.
mission, which had its lander and rover crash landed on the lunar surface in September 2009. The Chandrayaan 3 mission aims to uh, rectify the issue faced by predecessor successfully land a rover on the moon.
No, you're using present tense. Or it's already past tense. Hello, Aryan.
Oh, yes, sir.
You said Chandrayaan 3 aims to. No, not aim to. Already it has done.
Sir, I have made it before the. Let me say,
Before it landed, is it? Good. Yes. Okay.
the rover is expected to carry out similar scientific experiments as the Chandrayaan 2 rover. The
Mm-hmm.
primary objective of this mission is to further understand lunar surface, study the presence of water, ice, and
Yes.
gather data on lunar mines and lunar minerals and lunar geology. The
Mm.
Indian Space Research Organization faced several challenges during the Chandrayaan 2 mission, resulting in the loss of communication with
Mm.
the lander and rover.
Mm.
However, ISRO learned from these setbacks and aimed to rectify the issues for the Chandrayaan mission. In the
No,
in
so
this,
Aryan, can you tell me how it can detect water? What is the method to detect water?
yes, sir.
How to detect water on moon? You
Sir,
said that
no,
Chandrayaan 3 is going to detect water. How it will detect water?
yes, Sir, it would be in most ice form.
Hmm.
Um,
So how to detect?
sir, I may have written the
You may.
I have a notebook where I have written many things. Sir.
Okay. Okay. Go ahead. So maybe next time you'll explain to us how it will detect water when it is supposed to detect aluminium, magnesium, gold, things like that. How to detect water? Suppose your eyes are closed in your house. How will you detect water somewhere in your house? Your
Yes, sir.
hands are. Suppose you are
Sir,
in the house. Your eyes are closed. Your hands are closed. Then how to detect water?
yes, sir. I have, sir. The Chandrayaan 3
Hmm.
has another payload called Mini SAR. This helped
Hmm.
help detect the subsurface deposits of water ice in the
Hmm.
permanently shadowed regions with the craters near the South Pole.
Hmm.
Is a third payload developed by NASA called Moon Mil- Mineralogy
Hmm.
Mapper or M3 also had these molecules on the surface of the moon.
Hmm. Hmm.
So even I didn't understand what everything.
So no. Next time you'll explain to us, but I can give you a hint. You see, hydrogen also has got one nucleus, and there is an electron orbiting around it, isn't it? So suppose you pass hydrogen through a spark, or you ionize it, and if the electron comes back to the proton, no, it will emit a radiation. Now, all elements have got a characteristic radiation, characteristic frequency. So that is what there is a spectrometer they are telling, no, in the newspapers that they have got a spectrometer. This is what a spectrometer does. That you ionize an atom, and then when atom becomes normal, it emits a radiation, and that radiation you measure the frequency, and from that you can tell, oh, this is hydrogen, this is oxygen, this is magnesium, things like that. And that is the experiment which it is going to do. So if Mr. Raj also coming, joining us,
Yes.
Yes, sir.
Good evening, Raj sir.
good
Good
evening, sir.
evening.
Yeah.
So it's your
Yeah.
first time. So can you say something, Raj sir? Please.
Yes, sir, actually, Pankaj tell me to join.
Yes.
Pankaj,
Yes.
I know
Yes. Yes, sir.
Pankaj belongs to my native place sometimes. But today I have seen your detail. I am also an engineer and MBA, and I am the working professionals and staying at Mumbai. Just wanted to see what is it exactly. That's why I have joined over here.
Oh, yeah. So you are from engineering background, is it?
Yes, I am the mechanical engineer, 92 pass out.
From where did you pass out?
Shivaji University, Kolhapur. College was RIT Sangli, Rajar Institute of Technology, Sangli.
Oh, acha.
A long time
But
back it is, sir. 30 years back. 30 years back.
so you belong to which place actually?
I am Muzaffarpur, Bihar.
Acha, Muzaffarpur, where? Which place actually?
Muzaffarpur, Juran Chhapra. There is a place near Juran Chhapra, Mehdi Hasan Chowk. Then I
Okay,
have grown up there. I did 10th from Jilai School, Muzaffarpur. 12th from RDS School,
okay.
Muzaffarpur. Did engineering from here, Maharashtra. After that, I continue to stay over here only, sir.
Oh,
Whom I am talking, sir? Whom I am talking?
acha. My name is Chaturanan Mallik, and
Mallik, sir. Yes, sir.
I stay in Kolkata,
Sir.
and yeah, I am basically I was working in Bhabha Atomic Research Center. I'm an accelerator physicist.
Acha,
So
BRC Mumbai.
yes, but I was not in Mumbai. I was in Kolkata, where we
हाँ
have the cyclotron. You know,
हाँ हाँ है ना cyclotron.
yeah, the cyclotron. The biggest cyclotron in India we have that is in Kolkata.
Sir.
We have two cyclotrons. One cyclotron is a room temperature cyclotron, and one is a superconducting cyclotron. The superconducting cyclotron is the sixth largest in the world.
Okay. I have seen, sir, BRC Mumbai several times. I have visited BRC because I am the sales and marketing personnel. So for some business
Oh,
purposes, industrial filter I have supplied so many times in your BRC. The BRC maximum
oh,
executive directors knows me very well.
oh, very good. But I
Sir.
stay in Kolkata, so
I
and
can
this is
understand.
a
I can
part of
understand,
BR.
sir.
Yeah, it is a part of BRC, the institute. It deals with the nuclear physics. Yeah,
Mm-hmm.
so it is nice to have you actually, Mr. Raj.
Sir.
And Amarnath ji has also joined. He's a
Yes,
he is
namaste,
uh,
sir. And Sanjay sir also
Amarnath is
joined.
Yeah,
just now.
looks
Everyone
like
was asking what is the difference between normal computer and a supercomputer.
Supercomputers. The name suggests supercomputer very fast. Everything. There is a kilobyte, byte, megabyte, something like that
but
exactly that dimension I'm trying to remember.
yeah,
You maybe
megabyte
know in
is
it.
okay. So let me. I think since you are first time, so I think we need all to give you a brief introduction.
Sir.
So and I'll do, and then Dr. Sanjay ji will also give you introduction. I don't know if you other people also need to, or you already know them, because I'm not
Yes.
very regular in this meeting. My name is Amarnath Jha. I live in United States.
Sir.
Right now, I'm living in Princeton, New Jersey,
Sir.
and basically myself and Chaturanan Mallik, we both are from the same village in Madhubani district, and we are bosom friends from our childhood grade one. Actually, we only did
Right.
grade one together. After that, he had different path and I had different path. So grade one was the only common thing for two of us. And there is another friend who is not coming, but we have to try to get him. Hopefully, he will join one day. So that's our connection. But he's a physicist, and I decided to do the engineering in India from REC Srinagar. Now it is NIT Srinagar, and then I was working for government Bihar for 5 years, and I was not very happy with the government job. So my fire was kind of a little bit. So I said, well, let's go to do something different. So I came to the United States, did my master's, taught in a couple of colleges for 5 years as a professor of pre-engineering. That's how, if you guys don't know, just let me explain to you. In this country, you have to have the papers to work. So while I was teaching in the college, I got my papers. They call it green card, to stay as long as I wish and work in any company. As soon as I got my green card, I joined IBM Microelectronics in 1988. So from that day, I have been involved in semiconductor research and development and manufacturing, making computer chips. In that time, IBM was the leader of microelectronics, and later on, like now Samsung, Micron, you have TSMC, Intel, all these companies you hear about, they came later. But first, really, because IBM was the very first computer company basically in this country. So I have worked in research and development for both IBM as well as for Intel. And then on the supplier side, I worked for the Lam Research. Lindy is also in India. Actually, everybody is now in India. Lindy and Air Liquide. That's another French company. So this is on the supplier side. But what all my career has been in semiconductor research and development, how to make the chips on the wafer. I think it's hot in India right now. And I always say that I wish our leaders could have thought about it in late 70s when really everybody was trying to get into this, and 80s, then we would not be buying all the computer chips right now. Every telephone we use in India, we are buying chips from outside. Can you believe that? So, and that is the premium we pay for it. So it's
No,
very
India,
sad
India
situation.
now, sir, India is also going to manufacture semiconductor in Big Bay. It has everything
Yeah, but
decided. Even Vedanta
yeah,
is
so
also coming, or whatever Linde
yeah,
you said. Linde is
yeah,
purchased by today Tata, and Tata is announced, Ratan Tata especially, for entering a big way in semiconductor or maximum executive senior executive. They are importing from
good,
USA.
good, good.
They will
Yeah,
work for Tata, or they will stay in Mumbai and
yeah,
Delhi, or they will work for
yeah.
semiconductor
So
manufacturing. There is a
no,
big
so
plan,
I
big
got you.
plan.
I got you. So now, so this is a very good news that now we have plan. But
Hmm,
it is not the electric switch that you will turn it on. It is a
hmm.
huge $20 billion factory. You have to put it together. You have to
Sir.
get the machines from all over the world. Then you have to tune up the line. And so by the time you start manufacturing, it takes anywhere from 3 years to 5 years. You see what I'm saying? So it's one thing to say that we are going to do it. But when actually you do, Sanjay ji is also there. He's another semiconductor person. So you have two-person from the semi. He is in Singapore, so he'll give you more from his perspective in Asia, what is happening there. I'll give you from the Western countries. So we are far, far, far behind in semiconductor in
Hmm.
India. And that is the 100% fault of our political leaders. We had the scientific community to do it. In fact, if you look at the American companies, there is not a single semiconductor company where we are not controlling or we are a big stakeholder of the research and development. Okay, we are
Hmm.
everywhere in every company you can think of in very key position, and but Indian government ignored all our efforts. As an NRI, we all have been telling from 80s to join, to come forward. But Indian political system was never ready to accept that this is a strategic business. So we missed that one. So that's my background. So let's give to now Sanjay ji. Now you give your introduction to Raj so that he knows you who you are.
Good evening. Currently, I am in Delhi. I will be back to Singapore on 1st of September. So, I did my PhD from IIT Kharagpur and Technical University Hamburg Harburg in metallurgical and materials engineering. And I have worked for companies like General Motors, Rolls Royce, VDL, Micron, and I have gained experience in automotive, aerospace, and microelectronics. Varied experience in quality, in supply chain, supplier development, etc. And I'm very happy to be associated with this group started by Pankaj ji, and he has brought all the like-minded people who want to discuss on burning problems and share knowledge about science and technology. So I'm happy to join all of you.
So, Sanjay ji, you are not planning to come to Kolkata, is it?
Kolkata, not in this during this visit. I will be back. Yeah, but I will be glad to come and see you one day, definitely. Maybe in the next visit.
Okay, good. Thank you.
Yeah, this visit I went to IIT Bombay and I met a couple of faculties there, delivered lecture, and also in Delhi I visited in an industry, delivered lecture there. So maybe in next visit I will definitely visit Kolkata, sir. My
Sure, good.
promise.
Thank you.
Yeah, yeah.
Just sir, Dr. Sanjay Jha, are you same Sanjay Jha of Motorola or some other Sanjay Jha?
No, I'm Sanjay Thakur, not Jha.
Acha, Sanjay Thakur. I believe
Yes.
that
Yeah,
he told us Sanjay Jha from Singapore. So there is Sanjay Kumar Jha,
oh,
who is the founder of this mobile, whatever we are using. The first
Right.
mobile in world, it was invented by him from Motorola CEO, Sanjay Kumar Jha, who stays at USA.
yeah.
He was the
You
IT
know one
bashing guy.
thing.
Sir.
All the people who starts with Sanjay name, they are all top scholar from Mahabharat time to now.
Yes, you are right.
So you cannot get
Yeah.
that name. So You have this
Sir, sir.
Sanjay, then you have Sanjay Jha, one in America, one in India. So all Sanjays
Uh,
are, Sanjay of Mahabharat. They are all great,
Right.
great, great people.
This,
Sanjay,
the,
you are very right. So Sanjay is very powerful name because of mobile
this,
as every world by each person of world maximum are using. And you see
right,
that is invented by only Mr. Sanjay name Sanjay Kumar Jha, or
right,
who's the Madhwani guys and born and brought up in Delhi. Today he is a
right,
green card holder in USA. He is also the founder of Motorola as a CEO. He was there. I do not know today where he is. Just Sanjay has
okay,
come
Okay,
and I
I'll
believe
tell
that
you about him. Okay, let me tell you about him because I have worked with him, Sanjay Jha.
he
So,
worked with him.
and yes, and I'll give you a little perspective of American working style so that you will get to know that
Sir,
how the system works here. Okay, so
sir.
Sanjay Jha, everybody knows he was at one time in Motorola highest paid Indian CEO, like among
Yes.
that was his reputation that he was so he worked for that company Motorola, and then he went to what is that company who was supplying big time to Sanjay ji, who was supplying to chips to Apple computer. I'm forgetting the name. Qualcomm. Then he was there, and
Foxconn.
then yeah, Qualcomm, and then after that, there was a research and development center in New York, which had become a defunct. So all the Marwari Sikhs of the Abu Dhabi, they had tons of money. They revived that with the help of New York government. They formed a company called Global Foundry, and
Mm-hmm.
then it acquired a couple of plants in Singapore, a few other places, and then it came really from the zero. So it started it growing up, and then he became the CEO of that company. Okay, so now how did I know him? So when he became the CEO of the Global Foundry, of course his office was in California, San Jose area, and then company has become big, and it was still a private held company. Private held company means that Abu Dhabi's sakes they were controlling the whole company. Okay, but what was the objective? The charter they gave to Sanjay Jha that I want you to make this company paint all the dent, start making some product and fix it, and then we will make it IPO in the New York Stock Exchange, and then we will recover our money, and then the stockholders will be the owner of it, like a stock market happened, it becomes a public company. That was the charter given to him, and then he became the CEO of the Global Foundry. So he started working on that. So what happened is that at that time, IBM Microelectronics, where I had started my first technical job, 1988 to 96, that was still IBM. And I had gone from there, IBM, to let's call it to the West Coast in Intel and few other companies. And my son moved to this side in New Jersey, so I decided to come back to IBM again. So I was 2015. I was back in IBM, same New York, and then one day, Sanjay Jha, CEO of the Global Foundry, he decides to buy that IBM Microelectronics division. So I am in the fifth scale, and then we have a big party where Sanjay Jha comes because he had just acquired the microelectronics division there. So I had chat with him naturally there in that party. Everybody was there, and he was taking around talking to everybody. So overnight, I become from IBM Microelectronics to I became a global foundry guy. Okay, so once he acquired it that one, so still we were finishing their 14 nanometer product for IBM at that time, research and development, which was going on, and it went until 2016. So he used to come for meetings and all that because, so now whatever work we were doing, now Global Foundry was doing for IBM on behalf of IBM for the central government. That project, 14 nanometer development, was for the federal government, and IBM was a contractor. So even IBM is a big contractor for the government. Okay, that's what the point I wanted to see and how the merger and acquisition happens, and in that process, and then the goal was that we, after finishing the 14 nanometer, we would move to Malta, which is the capital of Albany, is the capital of New York State, not New York City, and Malta is next door to it, where the factory of the Global Foundry is. And we were chartered to develop the 7 nanometer because 14 nanometer was already in the production everywhere, and now next node was 7 nanometer technology development. So we all the IBM development people, we moved in mass to Malta to work on that technology while they had factory. So we worked from 2016 end to 2018, but we were far behind because there are many reasons. uh, compared to the TSMC, we were far behind. And so 2018, Global Foundry decided to can this project, so we all got fired. All the top engineers of the United States working for IBM, who become overnight Global Foundry guy, who had 20-30 years of experience, we all got fired. Okay. But so this is what happened. That's one thing. And before we got fired, Sanjay Jha was fired because he was not, the charter he had, that the 3 years they have given him that you develop the 7 nanometer, he was not able to develop it. And so he was first let it go, and then all the technology researchers, which people like me, we all were fired. Okay. So this is how America works. You get a project, you get a timeline, you do it. Otherwise, doesn't matter who you are. It's not India where, once you are a from a established family or that, nobody can touch you. And then once he lost that job, Sanjay Jha, he never recovered. So now he's doing something else, finance and all that, but he was done. Semiconductor chapter of his life is done. So here you
Oh,
go.
Understood,
very.
understood.
Oh, this is very, very bad. Actually, I didn't know this.
Huh? Yeah.
Yeah, this is
No,
very
you
bad.
guys.
Yeah.
No. It's not very bad. Why you are saying in very bad? He was given a American system. That's how it works. It's very effective. You promise that you will deliver this, then you have to do it. If you don't deliver it by date, suppose if you are a private contractor, then the other party can sue you, that you said that on 15th of December you will deliver 7 nanometer, and now it is 15th of say next year, and you are still working on it. So here I could have sold that on last year on 15th. I have loss of 1 year. So here is my damage lawsuit, and now you give me this much money. This is a very normal life in America. You
No, but I tell
nobody
you,
is.
no, Amarnath ji, in a research field, no, that the result cannot be time bound, isn't it?
No. So keep
See,
in
you
mind.
all worked for 14 nanosecond, but that time that was a new field, isn't it?
No. So there is a difference. Now again, for you guys, there are two things in physics: research and development. So research is fundamental research. There you are right, Mallik ji, that you don't know whether you will have a result or not. But development is using the research, and so that is engineering. So there you cannot escape. You have to say, if that you already basic technology is known to you, now you are making it manufacturable, you want to make it high volume production, that's all you are doing, right? I mean, like in the research you can do like one chips, two chips you can make, few pieces you can make, that's good enough. But now you have the technology understanding of how you make it, now you are translating that into high volume manufacturing. That is the development, how to do it. And so for this development, you have to have the dates. One thing. Second thing is that you are not alone working. In the Western world, you are competing. So we were working, TSMC was working, Intel was working, Samsung was working. So there is a huge competition. So whoever comes first in the market will make the money. The follower guys who comes later and later, they will not have that margin. So there is a race who is going to go on moon first. Okay. So this is the mindset America has. So this one Indian mentality that we are working on it, we'll get it there. it has, it does, that is the difference. That is the Indian thinking, and that is the American thinking, and that is the reason why America is on the top. Okay. So when we plan, we have already product launch date. Suppose, for example, at Intel, IBM, I was never part of the product launch because it was a very research oriented development place. But in Intel, I was in the high volume manufacturing. Of course, I interacted with the research. So in the high volume manufacturing, the Intel works. You have a research and development group in Oregon State, and then factory was in Arizona where I was. So already every 2 years new technology used to come. So you know that every 2 years Intel would come up with next generation of chips in those days, in old days. Okay, so 2 years is how much? How many days you have? Let's call it 365 times 2. How much is that? Any mathematician? Where is Aryan? He can tell us about that one. So 600, 360 times 720. Let's 720 or 730 days. So already the day, let's call it that one technology is introduced in the manufacturing today. The same day in the research and development program is made for the next technology, and you have 2 years time to develop it. So now their gain chart in days, you have how much? 760 days. So you will start making a gain chart as a planning group. What you are going to do in 760 days, that product will be delivered, and then everything gets monitored. Did we meet all the requirements, all the expectation, all those kind of deadlines, whatever it is? What is the problem? What do you? So that is the job of overall program management and project management. So it is very heavily monitored in this country. Everything, you have no room. If you fail, you become Sanjay Jha. You become Amarnath Jha. You get
No,
get to
Amarnath Jha
go.
is a good one. Amarnath
Yes.
Jha is not failure.
And almost you will be surprised that almost all the engineers in this country, we go through that one. I have gone a couple of times. And but the good thing is what happens. Suppose, like for example, when we all got fired, the very next day, all the other companies came, and they were in the newspaper, and there was all the hotel was booked by all the companies, and everybody who got fired, they got hired by somebody within a month. So that is the culture here. That now, so suddenly you will find that everybody went to different country. I went to. That's how I moved from Global Foundry to Air Liquide, which is a French company. They are supplier for the semiconductor, and every my friends, they went all over the places. You name it. So it's the same semiconductor crowd which moves around. It's like same in the pot. You have a part water. That water is particles are moving around. Technology wise also it's the same thing. Sorry, I took too long. So now let's give back floor to all of you.
Sir,
Oh, okay. Aryan has left.
Oh yeah, he
now
must be.
Mrityunjay is joined. So Mrityunjay, you have any question?
Good evening, sir. Good evening, sir.
Hello, good evening.
Sir, today I went to astrophysics workshop at IISc. So that's why I joined late. So they were telling about astroparticle physics, like
Yes.
particle physics and astronomy combined. How do we detect the antiparticles that are coming from coming from space? So, do you have any instruments for detection?
So now this astroparticle physics, is ultimately in the universe, all the processes are there, which is basically the done are there, which where only not only protons but all the fundamental particles are taking part. That is why it is the particle physics and astronomy people, they combine together because all the processes which take place, so the fundamental particles are involved. When you talk about the antimatter, it's very interesting. By the way, you'll be surprised that if you go to a diagnostic laboratory nowadays, they do this scanning, PET scan and all that. So PET is what? PET is positron emission tomography. And
Yes,
what
sir.
is a positron? Positron is an antimatter.
Yes, sir.
So fundamental principle of any detection of any antimatter is that any antimatter, if it combines with matter, it gets destroyed. Not destroyed, it gets converted to a electromagnetic wave. Like say in our that when you go to these diagnostic laboratories, they do PET scan of your brain, heart, things like that. So it's the positron, which is emitted in the reaction and combines with the electron, sends in a gamma ray, and gamma ray is detected. So this is a very simple procedure of detecting any antimatter. The major question which astroparticle physics people are right now trying to understand, why there is so much of matter and less antimatter. What happened to, because when the initially universe was created, the amount of matter and antimatter was the same. But somehow the antimatter has vanished. There is more of matter now. This is very interesting question, All physicists and astrophysicists, they are trying to work on that. So
Yes,
as
sir.
you said, Mrityunjay, the detecting antimatter is, you are detecting, you see, you go to any diagnostic laboratory in your town, they have a PET scan. And there, of course, there are many other ways. Of course, I just made it a very simple one.
Yes, sir.
But antimatter is there around us.
Sir, but we can't detect it, right? And if it's there around us, it may annihilate us.
No,
Sir, why does
detect
it
means,
annihilate?
no, how you detect it, like positron is a, antimatter means opposite of the electron. So electron has negative charge, positron has positive charge. The mass remains the same. So when these two combine, they will emit a gamma ray. You detect gamma ray, and then you say, oh my God, so just now one electron and one positron, they have combined, and that is a particular frequency it generates. So you detect that frequency, which you do in the PET scan if you go there in your lab, diagnostic laboratories nowadays, wherever PET scan is there. In your town also PET scan will be there. Mrityunjay, you are from Bangalore, isn't it?
Yes, sir.
So you'll find a lot of diagnostic laboratories where PET scan is there. They are utilizing by detecting the electron positron annihilation and detecting gamma rays. So Aryan has a question. What about Aryan? You have an answer to this? So actually, there are more questions. Rajji, I was asking that in Mumbai, how are they celebrating this moon mission?
Sir.
No, this moon mission, how they are celebrating?
Hello, sir.
Where in? No, I'm asking Rajji. He stays in Mumbai.
Oh, I think he
Sorry,
left.
sorry, I was on a mute option. I was on mute option. Okay, sir,
Yeah.
tell me.
How are
So
people celebrating?
Actually Mumbai all has in Marine Line, Marine Drive. They all have made a big celebration there in evening also today because a big way. And also Narendra Modi announced over here na 23rd date is that will be the Edo Space Day. This 23rd of August will be National Space Day. National Space Day. This is a big poster, big brochure everywhere they have put up. A big hoarding is over here in Mumbai, and all the Mumbaikar is very happy. Rather, all entire India is very happy for that.
Oh, and what about Mrityunjay in Bangalore? How they are celebrating?
So here, there people are like much of a scientific way. They're like not celebrating in a extravagant manner, but they're like hosting watch parties and like discussion and workshops, seminars. They're like educating more people here. Like
Oh, good.
even like some small space companies, small startups, they're partnered with cafes, restaurants, so they're like hosting a conference party and all for space enthusiasts.
Sir,
Oh,
I will yeah intervene it. Yeah, there is a Nehru Planetarium in Mumbai. It is on Worli.
right.
Nehru
Yes,
Planetarium. They
yes.
have also used. They are taking classes and they are teaching the people. And the free of cost, you can go and see what India has achieved and which way we can get advantages from moon and everything. They are teaching also the free of cost. Free show is going on here, Mumbai, Worli, at Nehru Planetarium.
Yes, sir, same here, sir. Actually,
Any
there's also
Hmm.
So, Malikji, I have a
Yes.
question for you. Yeah. See, I become very, very upset when he told me that name of the planetarium is after Nehruji. You know, this is very sad in India that politicians they take credit for everything and they are everywhere branding themselves. This should have been all the planetarium. They should be after all the ancient physicists, like all of them, Bhaskaracharya and all those. There are a bunch of them. We talked about um, Vaisheshik Darshan, which is I consider Kanad as a first physicist of India. Yeah, I have to still send you that book. You asked me that. I mean, when I read that book, I said that this is the high school physics he is talking about, and then we never give even any mention, any respect, or anything. And then all the politicians they hog all the name. I mean, this make no sense that planetarians should be in the name of Nehruji,
No,
right?
Jha Sahab, slowly it is a changing.
Yeah,
Slowly, Narendra
yeah,
Modi is changing. This is the, but
yeah. So
overnight it cannot be changed.
basically,
Like
as a technical person, we should fight for all those things. This is our right. We
earlier it
contribute
was
in the
Rajiv Gandhi
national
Award.
building.
Rajiv Gandhi Award. There is a game. Now it
Yeah,
has been changed as a Major Dhyan Chand Award. It has gone
good,
slowly.
good.
They people understand, but
Yeah,
it is
yeah,
a, you are right. Since long
yeah.
time it is
I mean,
coming on everywhere.
yeah,
Nehru Gandhi, this Gandhi family having
especially
this.
the Nehru family, they kind of branded their name. Everything is after
Ah,
them. Nehru,
mm,
Indira Gandhi, Rajiv Gandhi, this, that. I mean, this is too much in India,
mm.
and nobody challenges them. So, as a technical
Now it
person,
is
Amarnath
a
ji,
challenging. BJP is challenging.
good.
Amarnath ji, the people in science don't bother about the names. What is there in a name? You
No, but
you
no, no,
call
no, no, no,
rose
no.
by you
This
call rose by any other name, it will still give a good smell.
no, no, no. This
Ah.
is this is the look.
But
This is the
look,
here
no,
comes.
one more thing let me add. You see, the Chandrayaan 1, where it fell down, that was named after Jawaharlal Nehru.
See why? Again, another one, another mistake,
Acha,
and why it
but
happened?
now there is a controversy has come now. He has named where Chandrayaan 3 has landed, has named it after a Hindu god, Shiv Shakti.
Yeah. So
So
this
now
is
the
sucks.
whole
Yeah.
day this
Shakti is
he is
Shakti.
talking about it.
To answer your question that scientists don't bother, I have to take over from here. And now I'm going to talk about intellectual property for all of you. The physical properties you all know. You own a house, you own a car, you own a tree. I mean this and that, right? You can even own a land on moon. I heard there was an Indian actor who died from Bihar. He used to own a land on moon. I don't know how you could how you could uh, Sushant Kishore or something. I heard that he used to look at the moon every night and he had a land piece on the moon. Somebody sold him the land piece. So, what I want to talk about a little bit about it, this is a very interesting talk to connect uh, that, that before it was a kind of philanthropic science research. Now we talk about monetizing. There is a money involved in it. Okay. So that of course this is a Western concept. This is not Asian concept. Asian concept is that you do it for two reasons. For your swanta sukhai, for your own happiness, or for the betterment of society. But the Western thinking is that no, 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 you do it also for money. For the money making, you do the science. You don't do it just for the fun. Okay. So what that happened that in the last century, 1800 something,
Yes.
United States established its first U.S. patent office. I think it was time
Hmm.
of Thomas Edison. Thomas Edison was known for a lot of discoveries. Only some of them we use like gas bulb and all that thing. But Thomas Edison
16,000.
also, huh?
16,000.
Yes,
16,150 discoveries.
exactly. So he has the he so basically patent office was made. You can call it. It was right in Edison next door where
Your
he
sound is not audible.
All right. Now, is this audible now? Is it better now?
Yeah, it's okay. Now
Yes,
it's
yes.
Yeah.
okay.
Okay. Now I have to speak near the phone. Maybe battery is weakening. So the U.S. patent office was made in the last century, like 1800 something, and highest number of patent was for Thomas Edison. And Thomas Edison, basically, what was the? It was a kind of, you can call it, scientific discoveries were taking off in this country. That was the time. Then you had few things going on. Like for example, Wright brothers was coming with the with aerospace, like first airplane. Mr. Ford was coming with a car, and he was coming with new techniques how to do the mass production of car. Then Tesla was coming with the alternative electricity. DC was Westinghouse. So these are the top guns of their time. They were now jumping into science, but they were not doing it for just the sake of public or for their enjoyment. They wanted to make money out of it. So how do you make money out of it? From the research and development. So this was decided that we will have to patent everything new research, and then when you patent it, whoever is the inventor of that patent or that company, they will have exclusive right for first 20 years to manufacture products on that. Nobody else can use that patent to manufacture the similar product, which normally we do in India, right? And then after 20 years, other people, there was a rules and regulation put in place that how other people can do it. But suppose if you want to use a license of, say, Thomas Edison, whatever one of the his patent, in the first 20 years of his that patent's life, then you have to pay uh, license fee or royalty to Thomas Edison for that one. So that's how Thomas Edison, when he made this 16,000 product, he didn't have any factory. He was completely R&D place, and he just made the patent. His factory was producing patents only, intellectual property. And now he made money out of this, that everybody, say Amarnath Jha or Raj or Naveen, he wanted to use his patent. So we all paid to him for that using his patent. Like, for example, some bulb company went to make the small bulb for the household. Well, he has to pay royalty, just like we used to pay in India. Every time you listen to Lata Mangeshkar song on the All India radio, she get paid for it a little bit or similar type. So that is what the history of the patent is. And so from that time, all the discoveries have been started being patented. Tesla has the all the alternative AC. That was his. He and Westinghouse has a fight for that one. That Westinghouse wanted to continue DC, but Tesla had come up with this one, and finally they agreed that okay, we'll work together. But the thing was that his patent was in the name of Tesla. So Tesla said, "Fine, I'll not charge you anything. You go ahead and convert this into product. I don't have. I'll not charge you because Westinghouse said that I don't have money to pay you royalty." So this is the. So this is one. Okay, a patent. Luckily, I have one patent from IBM too on the semiconductor. Just for your information. So that is one intellectual property. Now it is getting popular, and how people make money. Second part of is the copyright, which you all are familiar. So I'm not going to talk too much about the copyright. That it is like procedure and product, how you do marketing. These comes under that one. That is another intellectual property. Third thing is the publications. That's another intellectual property. that if you use somebody's publication for anything, like you refer it, you have to pay for it in this country. You simply cannot use my research publication for your benefit, and just you have to pay me certain thing or my company. So that is the third. And the fourth, there are two other things which is not in the public, which is called formulas, and then and second thing is the trade secrets. So formulas is like, for example, do you know what is the top formula in the world? Formula for the Coke you all have drank in India and everywhere else. But that formula is the top secret where it is kept. It is like lock in the lock in the lock in the lock. It's very well guarded secret. You can call it formulas. So that is another intellectual property, but you have to, it is like your private property. So it that intellectual property you have to guard. It's not in the public domain. The other thing is called the trade secrets. The trade secrets is that certain things uh, uh, which you research, but you don't want to bring it into public domain. For example, I have two trade secrets with IBM for my research in this time when the second time I came. So what is what? So so they don't want to patent it. Uh, they don't want to patent it. They want to use it, because if they patent it, that anybody else can use it for next 20, after 20 years they can use. If they use now, they will pay royalty. But if they think that this item, this research has more longevity, then they want to milk it for a while, and then later on, maybe on some day, they will patent it. So researchers, they get paid anyway. Just like for example, for the trade secret, I got paid exactly the same amount, all the contributors, just like you get it paid for the patent. But only difference is that trade secrets are not in the public domain. Only IBM knows that. And then, it is in their intellectual property section. Everything is documented, that who invented this, who were the people of the this, that, which site did it, all that. And then how long they are going to keep using it as a trade secret, and when they will change from the trade secret to something different. So now you got some, how the Asian mind and Western mind is that now you can see that we are paying for the water too, right? They know how to monetize everything. They don't like to do anything free. So here you go.
Yeah, very nicely. Okay. So Amarnath ji, I will take leave now. Pankaj, I will take leave. I have to.
So again, all of you, congratulations for Chandrayaan. I think it's time to go anyway for all of us. And see, that's another thing. In the science, you fail, but if you keep doing the test, you pass. That's how the science is done. So when the 19 we failed, we knew that one day we are going to be successful, and this is a big thing for all the scientific community. And again, this is what I was. Now it is the first our research in the modern time where we can tell to the world that we did it first. So congratulations, all of you. Everybody should be happy, and of course, it is a thing for the world too. But again, whoever does it first time, they have the name. Sports, same thing. There are teams, but whoever is the first, they get all the credit for everything, all the thing. Winner. All right.
Yes,
So
very good.
good.
Thank you.
Yeah. Thank you, everybody. Pankaj, I want to ask
Thank you.
something, so
Thank
you
you for
stay.
the time. Good night.
Bye. Pankaj, you
Okay.
stay a little bit. I want to ask.
Okay. Okay.
So, Pankaj, what I was going to ask you is that, you know, uh, uh,